Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars, study manuals, both for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation, at least tax-deductible to the extent allowed by law, to support our students, please go to smarturl.it/help ISU actuary. Here's the problem for today. For exam FM, you are given that F is the amount in the fund at the beginning of the year. There are n cash flows during the year where each cash flow CK for k equal 1 through 2 through n is made at time t sub k for t between 0 and 1. And I is the amount of interest earned during the year. Consider the formula. I, lowercase I, is equal to I, big I, divided by f plus the sum from k equal 1 to n, c sub k times 1 minus t sub k. Determine which of the following conditions produces I closest to the annual effective yield rate. Note that this formula for I is the standard formula used for the dollar-weighted rate of return in the account, because it has the amount of interest divided by the sum of each of the amounts put in or taken out, and each of them is multiplied by the period of time that it has been in the account, if it's negative, taken out of the account. So C sub k, if C sub k is negative, then this makes the element of that summation negative. So answer A is when each cash flow is smaller relative to F. Answer B, when each cash flow is larger relative to F. C, when each cash flow is larger relative to I. D, when the cash flows all have the same sign. And E, when the timing of cash flows is uniform throughout the year. And here's the solution. So this is the formula. It is based on approximation of compound interest with simple interest, and that's how we derive this formula. It is also called the exposure approach. The exposure associated with I produces results quite close to a true effective rate of interest as long as the net amount of principal contributed at time t is small relative to the amount in the fund at the beginning of the period. So answer A is the right one, and you should know this, because occasionally they will ask this. Please remember, this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.